It's time to get into the button of the USB rubber ducky, which is a really cool element of the hardware design that allows us to have some sort of input. We get output hardware-wise by the LED, which we're about to get to, but the button is pretty cool because there's a number of ways that we can use this, not only in debugging and developing a payload, but also in our payload for interaction to confirm whether things on screen are what we expect, or to execute different stages. And this really leads into some of the cooler elements of the DuckyScript Advanced or 3.0 language. So in this module, we're going to discover some of the new functions that you can use in DuckyScript with the button. And it's going to jump a little bit ahead because we're going to start seeing some code that we haven't really digested yet, things like while loops and if statements and things of that nature that we will get into in much more detail later. But suffice it to say, this is a really fun, good way to get into the languages, to get the basics down. The basic input and output of the duck is the button and the LED. And so let's talk about defaults for a moment. See, out of the box, as you might have already discovered, when you plug the USB rubber ducky into the computer, it's going to come out of the box as just a regular flash drive. It doesn't enumerate as a USB HID device. It doesn't do any keystroke injection. And it puts itself into an attack mode, which we'll get into, of storage, which essentially is what we like to call arming mode. It's a convenient way so that you can get access to the file system on the microSD storage. And that arming mode is also a default function of the button if the button has not been defined to do anything else. And there's a way that we can define what functions the button should take. And then there's also commands that we can use to, in that moment, interact with the button or wait for the button to be pressed. So I preface that to say that out of the box in your typical payloads and what we've demonstrated thus far, pressing the button is just going to quite simply turn your USB rubber ducky into a flash storage so that you can do, well, what you do a lot in payload development, the lather, rinse, repeat of tweaking your payload in Payload Studio, generating that inject.bin file, and loading it onto the USB rubber ducky. So what I'm going to do now is demonstrate that with picking up from our last payload, our Hello World and Notepad. And so let's just go ahead and take a look. And if you've been following along, you'll notice that our USB rubber ducky is back in its case. The button is typically, when it's just in PCB without the case, right there above the USB-A port. And we've done the modification using the sticker sheet that comes with to put the little kind of water drop stickers stacked up above where the button is on the case, so we can squeeze or pinch to press the button. So let's go ahead and demonstrate that default button press behavior. If I come over here and take a look at my target machine, and actually I can let's see, we can look at it as it executes, but I'll go ahead and switch. So I'll plug this in, switch to that computer, and you'll see it does its hello world. All right, well, if I now squeeze the USB rubber ducky and come back to the computer, you'll see it now enumerated as a USB drive with volume label ducky, and that's the default. And if I open up Explorer and navigate to the D drive, as it is on this computer, I can see the inject.bin and all of that jazz. So that is a quick and easy way to get to the USB rubber ducky in arming mode, and that is done by the button definition, which we'll get into in a moment. Now let's make this payload a little more interesting. So if we come over here to our Payload Studio, I'm going to go ahead and craft a little more complex version of that. So what was that? That was delay 1000, then we did GUI R delay 100 string notepad, enter, and remember I can actually do string ln notepad, which will basically just do string notepad and then enter for me, and then delay, I don't know, 200, and then string hello And hey, watch this. Wait for button press. Then string world. What do you think that's going to do? And this is one of the fun things about DuckyScript is it's so intuitive. I mean, what do you think wait for button press is going to do here in this payload? Well, let's go ahead and generate it, and then you can nod and smile and realize that yes, you were indeed correct. We'll download this payload, save it to the Ducky as inject.bin, and we're going to replace. It's going to overwrite that. I see in my little Chrome window that it's finished downloading here. So now I can go ahead and yank it from my Mac on this USB extension. And now just go ahead and plug it into this Windows box. And I'll go ahead and switch over to the Windows box so you can see what's going to happen here. We plug it in, hello, and it's just sitting there. Great. So as you might imagine, if I come over here and squeeze, it types world. And now if I press it again, because the payload has completed, there's nothing left. If we come back over here to our payload, and I'll close this console here, you'll see we're at the end. We're on line number 9. It's finished typing world. There's nothing left. So now the USB rubber ducky is just waiting for some more instruction. In this case, it's idle, so it's going to launch the default button definition if I press the button. So if we come back over to our Windows computer and take a look, I'll squeeze the button, and once more it enumerates as mass storage. So that illustrates the wait for button, and there's a lot of ways that we can use wait for button press within code. It's going to get way more fun and complex when we start doing functions and logic, but we can just use that simply to execute the first portion of a payload and then nothing else unless we, well, in this case, squeeze the USB rubber ducky to press the button and then execute some next bits. But we can also define a what we call a button definition, which is kind of like a special function that is always tied to the button. I say always with an asterisk, always anytime that we are not, in this case, waiting on the button. So as long as we are not here in the payload, then this special thing called a button definition will execute. Let me show you what I'm talking about. I'm going to find an example here. So if what we did was, and I'll of course begin this with delay 1000, this right here is a button definition. It defines what behavior the button will perform if it's pressed. And in this case, it's going to say string, it's going to type the button was pressed, and then stop the payload, right? Stop payload we'll get to later, but essentially it does what it says on the tin. Actually, I'm going to modify this. I will say attack mode storage, and then we'll do the button was pressed, press again for storage, and then wait for button press, and then attack mode storage and stop the payload. So what this means is anytime during the payload execution we press the button, this little block of code will execute. And it doesn't mean I don't have to have stop payload in here. I can take this out and it'll continue executing as I expected before. In fact, if we do attack mode hid storage, so both keyboard and flash drive, then we can just have it so that the payload will continue executing. And this payload is a while loop that types period and then waits 1 second. And it does that forever because it's a while true. We'll get into while loops soon, but suffice it to say for now, this is going to continue writing period. And any time during it writing period, I can press the button. It's going to say the button was pressed, press again for storage. It's going to wait for me to press the button, and then it's going to enumerate as hidden storage. So let's go ahead and generate that payload. And I see I have an error on line 12, which is end while. My end while needs an underscore. So yeah, in the same way that end button, so end underscore button. And that's just me typing poorly. All right, so generate payload, download payload, and we put it on the duck as inject.bin, replacing that file. Great. Unplug the duck, come back over to our Windows box, and we'll go ahead and plug that in. And I'll switch over here so you can see. Let's clear this out. I like to just keep a notepad window open at all times when I'm developing. Go ahead and plug that in. And as we expected, it's just going to type a period every 1 second because it has that delay in there. All right, so now I'll go ahead and squeeze the USB rubber ducky or press the button, and it's going to say, hey, the button was pressed. Press again for storage, right? And notice it's not typing the periods anymore, right? It's because it's stuck in the element that we were looking at before. It's stuck right here in wait for button press. And so this is the element I'm talking about where the caveat of the function is. Because if we're waiting for button press, then that overrides the button definition. But as long as we're not waiting for button press, anytime you're pressing that button, the button definition is going to execute. So in this case, it's waiting on me to do that before it goes into attack mode, hidden storage. So I'll go ahead and do that and squeeze the duck. And it now continues doing the periods, but we also see that the D drive is back. And so if I open up Explorer, there's the ducky. By the way, you hear that ding? Because I'm still typing a period, in this case, into Explorer. And Explorer is saying, I don't know what to do with that. Period's not a keyboard shortcut, so I'll do the error stuff. So if we minimize that and go back to Notepad, we will continue seeing it type its dots. So, yay. And I can do that again. If I press it again, there we go. It was pressed again, waiting for storage, or waiting for the button to press. And at least now I got it to stop typing, and it is still enumerated as flash drive. So that is the button definition. And you know, we can get really complex with the button definition. I'll show you an example here. So if I come back to Payload Studio and look at this new example, we can see here that our payload, just as before, the crux of it is this while true string period delay 1000 and then ender while, right? So it's just going to keep typing dot. However, it's going to give us some instructions before. It's going to say press the button twice to see how it works. And what it is this is an example of a nested button definition. So what happens is our first button definition is right here, and this is indented so it's easier to see. So this is the first button definition, and it'll say the button was pressed once. Great. But then within that button definition, there's a new button definition, and that is going to override the first definition. So what'll happen is when we execute this payload, it's going to give us the instructions, and it's going to say press it twice to see how the nested definitions work, and then it'll start writing period forever, infinite loop. And the first time we press it, it's going to say the button was pressed once, and then this new button definition will override the old button definition. And so we can nest as many as you want until you're blue in the face. There is a limit, but we're not going to realistically get to that. And so I can compile this and we can take a look at it, or you can take my word for it. That's essentially what it's going to do. Let's go ahead and move on and go through some of the other examples and some of the other commands to get a better understanding of this. And I implore you to try the examples that you see below as well. But for brevity, I'm just going to go ahead and show this next example. So now let's introduce another command. So we've already covered the button definition function, as it were, the wait for button press. So let's talk about disable button. So disable button right here is going to do exactly what it sounds like. That's the nice thing about DuckyScript. It's very human readable. This is going to disable the button. So we have a button definition just as you normally would in a payload that utilizes the button. And again, and I don't know if I've emphasized this enough, but if you do not specifically put a button definition in your payload, then there will be a default button definition. That is, press the button and it goes into arming mode. It'll enumerate as attack mode storage. It's just a flash drive. So don't worry about it if you're not getting into the button. Just know that if you're not strictly defining it, it will always be there for you to get your USB rubber ducky into arming mode to make it a storage device. But coming back to this payload in particular, this will never execute. And that's exactly what it says with its string. It will never type this. And the reason is because once we've defined this button definition, our disable button is going to prevent the button from doing anything. And then the rest of the payload is just as before. It's going to continuously press period or type a dot on the screen. So that's how you disable the button. And the reason that's useful is you might want to have a nested situation where you at some point want to disable the button. Maybe you don't want the target to ever accidentally press or squeeze the rubber ducky, press the button, and get it to enumerate as storage. So depending on your operation, this may indeed be what you want. You could in fact do, here, let's take this a step further. We'll say, building on what we just did in the past, and we'll say the button was pressed. Press again to disable the button. And you'll see what where I'm going here is, all right, well, now let's do another button def, a nested button def just as before, and we'll do disable button and then end our button definition, which is end underscore button. And there you go. So this is another example of how this would work the first time, but then not the second, right? So that's a little fun that you can have there. And another thing that we can do is, if we take a look at this example, is we can change our button so that we can enable it and disable it systematically. So what this payload does is we first define our button as just saying the button was pressed, right? Continuing the payload, which is all it does, right? Well, while true, again, an infinite loop, so everything that exists within this while true and end while is going to execute over and over. And in this case, it's going to disable the button. And it's going to say, hey, the button's disabled. It's not going to do anything for the next 5 seconds. We're going to delay 5,000. So within this 5-second portion of the payload, if you press the button, nothing will happen. But then we enable the button and we let you know, hey, for the next 5 seconds, it's enabled again. You can press the button and it will, in this case, just say the button was pressed, right? And it will continue toggling on 5-second intervals between the button doing something and the button not doing something. So something to keep in mind as you work with the button and you develop payloads is that if you disable the button and you're developing payloads and your payload goes awry or it's not at your final state, in the same way that we discussed with obfuscation, it's kind of what you want to add last, just for convenience sake, because otherwise you can get yourself into a state where, if I've disabled my button on this, in this payload, and now I want to put a new payload on here, and I plug this in and I squeeze the button and it does nothing because I've disabled the button, how do I get the files on here, right? Well, now I've got to open the case and get back to the PCB, and I have to pull out the micro SD card and pop that into a micro SD card reader. I mean, sure, you can do that. In fact, previously on the classic USB rubber ducky, that's how it was done. It's really convenient to have that button to get into arming mode, as it were. So I just point that out, that as you're developing payloads, keep in mind, if you don't have a button definition, pressing it will always get you into attack mode storage, into arming mode, as it were. And if you're going to play with the button definition, always give yourself a way out. Some things that we've done in the past in development to make things more convenient for ourselves is to nest button definitions such that if I want like this feature, okay, cool, and then I can add like a few where if I just keep pressing it, then I'll eventually get myself into arming mode, as it were. So go ahead and play with enable and disable button and the examples. And I'll point out that there are a bunch of internal variables that relate to the button that you can reference in the payload. And we're going to get into how to call these variables later on, how to set these variables. Some of these variables can only be read, some can be read and set. And it's helpful in developing a systematic payload to understand kind of the state of some of these things. So as we progress, we'll talk more about internal variables. A lot of times there will be a feature and then an internal variable that relates to that feature that allows us to have a better understanding of how it works or to manipulate it. So some of the internal variables as it relates to the button are button enabled, button user defined, and all of these internal variables begin with a underscore. So we haven't gotten into variables yet, so we're jumping ahead a little. But if we take a look at this snippet, for instance, we'll see that any internal variable is going to begin, well, obviously a variable begins with a $, that's a sigil, and we'll get into that. But internal ones begin with an underscore. And button enabled, now if it's true, then that means that the button works. And if it's false, then that means that the button disabled command has been run. So another way to put this is, we could do string the button enable command was run or not defined at all. And then similarly, we could do down here string the button disable command was run, or something to that effect. So there's button enabled, there's button user defined. That will let us know if the button is defined by the default button definition or if the user, myself writing a payload, has overridden that, as well as button push received. This is a really great one because we can actually get a lot more granular about our button, more so than just wait for button press. So button push received will allow us to say in that moment if the button was pushed. Well, in this case, there we go. And then we can reset it to false. And so this is a much more complex example that uses variables and counters and things of that nature. So I don't want to get too much ahead. But if you try these examples, you'll see how they work, and essentially this one is going to be able to tell you in that moment if the button was pressed. So it's a lot more complex than just a simple wait for button press, because the payload will continue to run. In this case, it's a while with a counter, and it's going to continue to do this until at some point until the counter is greater than 0, and it's going to subtract this, and it's going to say that it's 15. So it's going to do this 15 times. It's going to write a period with a 200 millisecond delay in between each run. And if you press the button, it's going to then type the button was pushed and then reset it to false. So that's kind of like, I know a lot of jumping ahead, but it's kind of illustrating the power of these internal variables. The one other internal variable to be mindful of is the button timeout. So button timeout essentially is an internal variable that allows you to specify how long in milliseconds the button will what's called debounce, or basically how long of a cooldown there will be between button presses. So with that default of 1000 milliseconds or 1 second, that means that in the previous example with the it's going to say pressed every time you push the button for 15 seconds, it would only do that for 1 every second. So if you set this button timeout to much lower, then it's going to allow you to press, jam on the button much quicker. Don't set it too low, you can run into problems with recognition, but in any event, that's, without skipping too much ahead, that's the button, and really introducing the concept of internal variables and the internal variables that are associated with the button and the definition. So you can see already, as we just put our toe in the pond, how much more complex this gets. And we're going to round out the basic input and output in the next module, talking about the LED, getting some feedback back from the USB rubber ducky without just keystroke injection. And that's coming up next.